Hi everyone and welcome to this new video. In this video I bring a new machine from ActiveBox. This is actually an old machine, it's called Valentine. It's an easy Linux box and it is retired. It's been retired for a couple of years, but I want to bring it because it will allow us to introduce a very famous vulnerability in the TLS stack. So in the protocol that protects the communications in the web. So I hope it is enjoyable, I hope you find interesting. If you do, leave some feedback. Even if you don't, leave some feedback, subscribe to the channel and keep watching. So to start off, let's create a folder for Valentine, and within that folder I'm gonna create a notes.org, an org file, where we're gonna write all the findings we find for the machine. It's always important to do this. So to structure the report, we can do first we have an enumeration section where we just write all the various useful information without structure, sort of. Then we have a foothold section where we describe how we got inside the machine. After that, we have a pivoting section to describe if we have to change from one user to another. And finally, we have the privilege escalation aspect in which we become root. So in pivoting, we can also do some privilege escalation, but I want to distinguish pivoting between a normal user and a more authenticated user and pivoting towards the root user, because after that, there's nothing else to gain. So this is it, and maybe here we can put the flags just for fun. So this is a good structure for reporting ActiveBox machine. In the enumeration section, we will put the outputs of the various command, while in the foothold, pivoting and privilege escalation, we will describe the vulnerability we found and things of the sort. So we can start with the machine. Now I'm already connected to the network, so okay, let's put this in another tab. Perfect, so now I can actually start the machine. I can ping, so the machine was spawned to the ActiveBox private network within the EP, which was, let me see, 10.10, 79. So this is the thing. A first thing we want to do is to add this to the etc host, so we can do it easily. So now I added the machine on my etc host, so if we cut the content of this and we grab for Valentine, we obtain this following line, which maps the IP address 10.10.10.79 to the domains, to the virtual host Valentine and Valentine.htb. Technically, it's the domain names because this is the DNS mapping. So to start off, we can do a simple nmap to check the open ports for the machine. And we can also do an nmap on all over the ports, which we can run in the background just to make sure that we cover all the scenarios. So we wait a bit and then we discuss the output. So after a few seconds, the result came out, so we can analyze them together. So the first port that was open, that turned out to be open, is the 22, which is the SSH port, and here we have the version of the OpenSSH implementation that offers this service, and here we have the keys which are used to fingerprint the server. So to authenticate the server, SSH authentication is done by the first time, the first login is not safe. You have to accept the key on your own. You have to do you trust the server? Yes. After that, this host key is saved within your host, so that the next time you connect to the SSH server, it gives you this fingerprint, and then you're able to match with respect to the one you have saved. If they differ, it means that someone else changed it, or maybe it changed on its own, and so SSH does not allow you to connect unless you explicitly tell it otherwise to do so. So this is here for server authentication. We don't really care about that right now. So, but having SSH on though is important because it means that users in the machine, maybe they have their SSH keys exposed in the file system, maybe they have password authentication or public authentication, so it could be like a way to get within the server. So another port that is open is the 80 HTTP with the Apache HTTPD 2.2.22 Ubuntu. And here the server doesn't have title, okay. And then we have the 443 version. So this is the SSL/HTTP version. Why is this the case? Well, essentially the idea is that initially there was just port 80, but port 80 was not encrypted. So every communication to port 80 happened unencrypted. So plain text communication, there was no guarantee on confidentiality, that is making sure that only authorized parties have access to the data, can see the data. There was no guarantee on integrity, which means that you could change the package during transit and the server wouldn't understand that something was changed maliciously. Obviously not a good thing. And of course, there was no guarantee on authentication, on replay attacks, on a whole different attack vectors essentially. So then they introduced SSL, which initially was designed to provide cryptographic services. Now then SSL transformed into TLS, so they just changed name. They were standardized by the EITF, which is the body that deals with the internet protocols, but typically you often see references to SSL. Just consider that now it just means TLS. So they decided to use a different port for combining the HTTP protocol with an encrypted channel. This is because in terms of protocol stack, SSL or TLS happens above TCP but below HTTP. So it means when we use port 80, the situation we have to imagine is we have the IP protocol, then we have the TCP protocol on top, and then we have the HTTP protocol. So below HTTP we find directly TCP. When we use port 443 instead, we use a different stack of protocol, which is similar but different. We have the IP, we have the TCP, we have the SSL TLS, and then we have the HTTP. So when you see reference to HTTPS, HTTPS does not stand for a single protocol. It is more for a stack of protocol. It says, I have HTTP, the normal HTTP, on top of a protected channel, on top of a protocol that offers cryptographic services for confidentiality, integrity, authentication, and so on and so forth. So this is why we see two different ports. They were standardized to act like this. And in the TLS port, of course, we have much more services. For example, we have the certificate of the server, which is used for the authentication aspect of the protocol. And we see the common name is Valentine.htb, the organization name is Valentine.htb, and so on and so forth. So we have the TLS certificate, so to speak. And after this, this is it. So this was for the first ports. For the entire port range, we see nothing new. So essentially we have SSH, we have HTTP, and we have HTTPS. This means that in terms of attack vectors of potential entry points, we have either we have to leak some kind of key from the user using the either HTTP or HTTPS server. So either this is an application bug, an application vulnerability, or we could also have a vulnerability on the TLS layer here, right there in port 443. A problem with the certificate or some kind of vulnerability that has to do with the implementation of the TLS stack. So that's the idea. I've signed all this in my org file. I suggest you do the same because this information is critical, and the way I save it is I just go by the name of the tool and then by the various commands I call on the tool. And maybe here there's a timestamp, so I don't need to put a timestamp, but let's say I want to put a timestamp. With org mode, I can do it easily. So I know when I executed this command to have some context. Perfect. And here, of course, I can put the example block, which contains the direct raw output of the tool. And then here I can put some text. But in this case, I don't need it because it's not really that important. So having said that, we can analyze the essentially web server. So we can go into this, we can go into Valentine. Let's see, okay, not here, of course. We have to go HTTP, Valentine. And we see this PNG image. So it's sort of like this heart that is bleeding. And this is kind of a hint for what's about to come. This file contains just an omg.jpg, so nothing interesting. I mean, one could analyze the internals of this JPG file. If we find nothing else, we will go and analyze the internals of this file to see what kind of bytes the image contains. It could be useful, of course. Okay, another thing that we should do is analyze the headers. So for this, actually, let's just open a burp. So here I've started a burp. We can go into proxy to open the browser, essentially. So we open the browser. And so let's put the Chromium browser here and the burp here, and then I'm gonna go target. I'm gonna add into the scope the HTTP Valentine as well as the do you want to stop sending? Yes, and then I want to add HTTPS Valentine. Okay, now I go into HTTP Valentine to check out the headers, proxy, history. So let's see here. The request we seem to have normal headers, and in the response also normal headers. We know that we have a PHP engine running, so this can be useful, x power pi, and the version of Apache which corresponds to the one obtained by Nmap. So really nothing specifically crazy about this. If we just view the source code here, and we obtain this image, I guess here I have to like remove this other binary to images, apply and close. So this image, I just have bytes of the image. Nothing too crazy about it. So like this row does not seem to be that useful with burp, I mean. So we can just remove this for a bit and we can just focus on okay. Okay, a typical approach that is done when we have a web server like this is to enumerate the directories and the resources exposed by the web server. Because even though here we do not see them, because we just see a single folder here with this simple HTML, there could be other resources which are not directly referenced into the HTML, which are however still usable by going through the web server and accessing them directly. So how can we enumerate them? We can use GoBuster with the dir method. So here I have the URL, which is -u Valentine. I think the -w for the word list, and here I think I can have in user share word list. Let's see what we have here. I would say dir, let's try this buster, directory list 2.3 medium. And then for the file extension, we saw that there was PHP, there is txt, and there is HTML, I would say. So let's see what we get. We get an index.php, we get a .html. So let's see, index.php. It goes back to here. Then we have a .html, we have a /dev, which gives redirect 301 to /dev/, so it's a directory, it seems. We go here, and we have two files. So this is an exposed directory. It is a vulnerability. It is a misconfiguration vulnerability, because when you have a web server, you should configure it to not expose the entire content of a directory. Now the issue is that if I expose the entire content of a directory, the attacker will automatically know all the files that exist in that directory. Instead, if I do not expose this content, the attacker will have to guess each file, and then for each file, he should obtain like a forbidden result or something like that. So here we have an IP key, which is this bunch of, it seems to be hexadecimal bytes. And why do I say that? Because each couple of numbers, the digits go between 0 and 9 and between A and F. Here's like F, there's nothing that goes other than that range. So it means that each of these bytes is an hexadecimal byte. So this is useful to have, to know. And then we have the notes.txt. So it says to do 1, coffee, research, fix decoder encoder before going live, make sure encoding decoding is only done client side, don't use the decoder encoder until any of this is done, find a better way to take notes. Okay, so it's talking about an encoder decoder. Let's try if there is, for example, encoder.php, not found, decoder.php, also not found. So it seems to us that for now, the focus should be on this IP key. Perfect. So let's download it. We can let the GoBuster go for a bit. We can download it. So let's just get this. We download this and we write into the hype key. Perfect. So we have this hype key. Okay, that's good. Now in terms of, let's see if I have the my x to ASCII. I do not have s to ASCII. So we can use something like CyberChef to decode this. So very useful tool to move between encodings. So I'm just gonna say from X to, I would say, let's see if I do this. Okay, so it automatically understands. And essentially, here I get an RSA private key. So this is the output that I get by converting each of these bytes into ASCII. So this goes from hexadecimal to ASCII. And why does this work? Well, because it's really simple. The idea is that hex is representing a number abstractly, and each number is also mapped in the ASCII. So there is this mapping that I can use. I can go to numbers, which is this abstract representation, and then I can move towards ASCII. So that's the idea of how we do this. And this is also useful to understand that information can be represented in many different formats. If I'm representing this key as hexadecimal bytes, it does not mean that an attacker cannot retrieve the original ASCII representation and use that key for malicious reasons. If you want to protect information, encoding is not the way. You should not encode. You should not follow this. You should crypt. You should use cryptography. Cryptography. You should use cryptography to encrypt, decrypt, and protect the integrity of the message, because the difference between encoding and encrypting something is that when you encode, you don't need any extra information. You just need the original text, you encode it into a different format, and you have the original format. It means that you can always go back. You go from the original, you encode, and you have the new, right? And no extra information is needed here, just the original text, which means that you can go back just with the new text. When you cipher something, for example, with, for example, AES, what you need is the original text, which is called the plain text, and a key. So now you need this extra information of a key to obtain the ciphertext. And if you want to go back once again, you also need the key. So you need, you sort of like conditioned the ability to go back to knowing the key. If you hide the key, the attacker should not be able to go back to the original text. Now, in this case here, we found this RSA key, so we can just save this into a file, and we can just write hype key decoded. So we have this key. Now, can we use this key to interact with SSH? Well, let's try. So with this hype key decoded, I'm gonna change the permission because otherwise SSH is gonna complain. And then I do SSH dash hype key decoded, and I have to log in into the Valentine machine with a single user, with the name of a user. Now, since here it's written hype key, we can try to log in with the user hype. Now, this requires a bit of guessing, sort of, but it's a good approach. So we can say, are you sure you want to connect? Yes. Permanently added Valentine. It's waiting a bit. And now it's asking me for the passphrase for this particular key. This is because this key is protected by a passphrase. It means that we cannot actually use it because the value we see here, it says encrypted. So this is not the raw text, the plain text of the key, it is the encrypted version of the key. So we have somehow to find this password. Now the way to go forward is to go back to the fact that, as we saw initially, we had seen this HTTPS. So this HTTPS. So I would say let's write here cyber chef decode hype key from X to ASCII to obtain this hype key decoded. Hype key decoded. So this is it. And in terms of cyber chef, we have the recipe here. So we can put the URL here. Okay, maybe it's a little bit too big, so we don't care, but let's just remove this input and let's just use this thing. Exactly. So that we know the recipe that we use. Perfect. Okay. So as I was saying, to go forward, we need to go back to the fact that there is TLS. So how can we enumerate the TLS attack surface area? There are various ways to do this. One way is to use the script testssl.sh. So we can go here and we can, let's say go to GitHub and we just download the release version. This one, I just download this source code because it's good enough. This is just a bash script, so let's put from the download, let's put it here. I'm gonna open the tar and then I'm gonna go inside. So this project contains this script which is called testssl. Now this contains a bunch of bash scripts that uses the OpenSSL library, I believe, to perform a bunch of tests on the TLS implementation of the server. So here we can specify -u HTTP Valentine, HTTPS, of course. Maybe it's not -u, maybe it's, oh, there's no need to -u, just the URL. And now it's gonna start to test out the various things that it's gonna find on this particular server. So for example, it says, look, this server is offering SSL v3. This is not okay because SSL v3 was found to be vulnerable to different attacks, so it should not be offered. So this is like a problem. Then it lists out all the ciphers that the server offers. These are the different ways in which encryption is granted to the communication. Now TLS, you have to think about TLS not as a single protocol like AES that uses a specific encryption scheme. The idea in TLS is to use many possible ciphers, and then in the initial aspect, in the initial phase of the communication, which is called the TLS handshake, the two parties, client and server, agree on which cipher to use. So this is like really important. Then it tells us about the certification. And then look at this. We have testing for known vulnerabilities, Heartbleed, which is CV 2014-01660. It says it is vulnerable, not okay. So essentially, we can stop here because we don't need the rest of the output, or maybe we can just let it run just for fun. So the most important thing that we found here was it is offered SSL v3, which is a vulnerability, and you're also vulnerable to Heartbleed. So we're gonna just pick out those stuff from the output. So I'm gonna copy this from the testing protocol, gonna put it into the notes.txt, enumeration, test ssl.sh. So this is the command. This is a command I use, very simple. So I would say, let's go here, let's do this. And okay, let's leave this banner, initial banner, and then say testing protocol, not okay. And then at the end, the thing about this one, testing for vulnerabilities. It's also vulnerable to CCS, which is a different vulnerability also found in 2014. So it means that we are dealing with a very old TLS implementation, SSL stack essentially, which is very vulnerable. Now, in terms of TLS vulnerabilities, some of them are really not easy to exploit, while some other are really easy to exploit. And this is the case for Heartbleed, for example. Now, what does Heartbleed allows us to obtain? Well, essentially with Heartbleed, we can read the memory of the server up to 64K chunks of memory. So this is quite a bit of memory that the client, so like we have the client, here's the server. The idea is that, let's say we have a TLS session established. So this went well, we have a session. At this point, the client can craft so-called heartbeat messages to check if the connection is still alive, to check if the server is still on. In these messages, the client can send up a certain size. He can say like, look, I sent you 64K of bytes, and the server replies with the same amount of bytes. Now the issue, which became a vulnerability, was that if the client sent like 1 byte, but then it told the server, look, I sent you 64K of bytes, the server would take the 64K of bytes from the server own memory. So essentially, by sending these heartbeat messages, the client was able to read the actual RAM memory of the server, of the SSL process that was running in the server. So this, of course, is very dangerous. And this is very dangerous because in this case, OpenSSL is linked with the web server, with the Apache implementation. So the server of the Apache, like through Heartbleed, we're able to read the memory that Apache has, a chunk of memory that Apache has, and this can means we might be able to read the content of different requests that go through the web server. So this essentially is the idea. Now at this point we need to understand, perfect, we have this vulnerability, how can we exploit it? Because to exploit this vulnerability, we would need to like write the packages that deal with TLS. But of course, we don't have to write it all on our own, although it's a cool project to do. We can use tools. So we can use tools, and also here I'm gonna put another nmap command because I think it's useful to quickly check for this vulnerability, which is nmap-p443, because we are targeting only the HTTP port. Script, we are using an nmap script, SSL, Heartbleed, Valentine. So this, and look, it immediately says it is vulnerable. Because now this vulnerability is well known, so there are a lot of tools for this vulnerability. So we can just also add this command. It's useful to do a specific test on this vulnerability. While the test SSL script is more general to do an enumeration on the TLS attack area exposed by a specific server. So how can we use this? How can we exploit this vulnerability? We can use essentially Metasploit. So we do mf console, we just run it, and we use a module which exploits this vulnerability. So after we start the console, we can do a simple search for Heartbleed, and then it says, okay, we have auxiliary, scanner, SSL, and of this module, we use the auxiliary scanner SSL OpenSSL Heartbleed. So we go use auxiliary scanner SSL OpenSSL Heartbleed. So at this point we set we show all the options, show options. We set the air host to 10, 10, 10, 10, 79, I believe. Let's check if it was 79 effectively. Ping Valentine. Yes, it's 79, so that's good. Then we set verbose true to actually get the memory. So set verbose true, and then we can say run. So once we run it, notice what we get here. We get a bunch of memory bytes, and this essentially is the memory of the server. So we said, look, leaking Heartbleed response, sending client hello. So like this is the first message that the TLS handshake has. Then we have the server hello with the server certificate, the key exchange, the hello done, and then the heartbeat message, which leaks the memory of the server. And so this is called Heartbleed. So we can just run it a bunch of time, and let's see what we get here. So we get something like, this seems like a possible flag. It kind of seems long enough. But other than this flag, we just see a bunch of bytes with repeated. So let's run it again. And let's see, we have repeated, still a bunch of bytes, nothing interesting. Okay, repeated. Let's run it again. Okay, look at this. Now this seems interesting. Here we have sort of like the headers, it's sort of like an HTTP message that comes from an internal decode.php that is exposed in the 127001. But here we have to consider that this is happening within the server. Here we also have the reference to var www decode.php. And then here we have application x www form URL encoded, content length, and then we have text equal to this. So this appears to be a variable which is found in an HTTP request. So let's consider this. So let's get this leak essentially, and I'm gonna put it into the nodes.txt. So we're gonna do metasploit. Then here I'm gonna put the module, which is, as we said initially, it is the, let's go up, it is this auxiliary this. Here we have module configuration. We put all the steps that we did for the modules. This is really important, otherwise we will forget for sure. So use this. Then we put the rost, and then we put the verbose true. Rost, and then we put the verbose true, and then we do run. At some point we have this. If we decode this, so let's take this. This seems to be base 64. And if you just decode this, so let's open a terminal. This is for burp. This is still going. So we do have decode.php. Okay, let's go here. Let's go into Valentine, decode.php. Secure data decoder, no data store on our server. Okay, this is interesting. And then we have the encode.php. Encode.php. So if I do something, your input, your encoded input. Okay, interesting. So let's put like script alert 1 here. Okay, so this is vulnerable to XSS. Let's put document.domain to check the domain which is executing. It's the domain Valentine, so it's not in a frame sandboxed. Your encoded input. Okay, I mean this is an XSS, but it's not really interesting for this particular case. Okay, interesting. And then we have the decoder. And with the decoder, I suppose we can just decode data. So let's decode this particular data at this point using the decoder here. Okay, you submit, and then it says your encoded input Heartbleed believe the hype. So essentially, when we decode the base64 string, we obtain, and here I put the base64 string just to make sure that we remember this one. We obtain this thing which looks like a passphrase. So the next step too is, okay, let's stop this go buster, and we can save the result now. So we can say, okay, look at this enumeration, go buster. Here I have the output, and here I have the command, which is a bit trimmed because of the way that the vterm in Emacs works. I don't like this, but I can retrieve the full command like as follows. Okay, here, perfect. So now we have everything, and now we have the passphrase, and now we can test the passphrase to essentially test if it works. So the passphrase is heart believe the hype. I'm just gonna copy it. I'm gonna use the key. So SSH-I is to use the key, is to use a specific SSH key. I say hype at Valentine. Then I wait a bit, it will ask me for the passphrase, and I will put Heartbleed, believe the hype as the passphrase. So now it's asking me for this passphrase, I just copy it, and I have access to the machine. So I am within the Valentine, here I can check, the IP is 10.10.10.79, I'm inside the machine, and this is the way we get the foothold. So at the end of the day, we can write into foothold, obtain through SSH authentication with RSA key. So we can put the final command here, and then we write the key was obtained by going to the essentially GoBuster thing, so HTB Valentine /dev a misconfigured directory which exposed all the file. We're going to the file specific. The file contain the key encoded in hexadecimal bytes. So the key was actually inside here /hype key. The passphrase was obtained by exploiting Heartbleed, with Metasploit. Okay, so this is good. So here we can put also the passphrase. I mean, here we just want to put the most important information. So I would say in this foothold, so to have a recap here, 2 core vulnerabilities, misconfiguration of directory, expose sensitive files. I would say let's just write core vulnerabilities, vulnerable TLS implementation to Heartbleed. So vulnerable Heartbleed, and here hype key. So essentially the way we got in was by using these 3 specific vulnerabilities. Now the misconfiguration of the directory, the fact that in this directory there was a sensitive file, and the fact that the server had a vulnerable TLS implementation which should be upgraded and fixed. And understanding exactly what it is that allowed you to obtain the foothold inside a system is crucial, because then from a defensive point of view, if you're trying to defend this system, you understand now what you need to fix. You need to change the configuration of the directories, you need to remove this sensitive file exposed over the internet, and you need to upgrade immediately your TLS implementation to more recent and modern implementations which are not vulnerable to Heartbleed anymore. So this is the way to the foothold. Now at this point we are the user, so let's see, we are the user hype. So what we have here, we have the user flag, of course. So we can cut this user flag, user flag. Okay, and then, so this is found in /home /hype /user.txt. Okay, then what do we see here? We see, for example, that we have a bunch of different configuration, among which we have a tmax configuration. So tmax configuration, perfect, which means that we have tmax. We can enumerate a bit the processes. So do we get here? We have the normal process up there. We have a tmax. Okay. So when we say tmux, so we say tmux /S. So let's try to understand this particular flag, what it does. Tmux help doesn't work. So let's do tmux h. I would say, okay, let's try to find, okay, no, here I have actually a tmux section, which I don't want. So let's do tmux as option. Tmux, okay, tmux options list. Tmux here in the main page, we have the, let's find the -S. Okay, -S, socket path, specifies a full alternative path to the server socket. If S is specified, the full socket directory is ignored. So essentially you have the socket to the server socket. So here there was a server socket, okay. So it means that when the root process started this tmax process, the socket that used was /devs/devsess. Let's go there. We see devsess. So this is essentially so as you can see here, this file is not a normal file. It is a socket file. It means that this thing is used to communicate with another process, to do process communication. And the idea is that, okay, if the root user did this tmax command, so where was it? Let's do it again. I think I lost it. So it was this. Let's try ourselves to do it. We do it. Now notice what happens. We have a tmax session, which is good, but the user that we have this tmax session with is the root user. So now I'm just root. it means that someone left this session open, this root session open, and we're able to use it essentially. And so we're able to go into /root, and we're able to cut the root flag. So here we can just root flag, root.txt. We can just put it here. And we also find this curl.sh, which is probably the script that allowed us to obtain this key. So this machine was made so that this curl script would continuously execute, probably with a cron job. If I do cron tab dash L, look at this, I have essentially every, I believe is that 2 minutes or something. So this is saying like every 2 minutes you execute the curl sh, which gets, it's sort of like it is used to put into the server the memory of this particular string, this base64 string, which we just need to obtain the passphrase. So of course this is all like a setup to make sure that we obtain that thing. And then we have our root flag. So in terms of exploitation, we are done essentially. And in terms of our report, no pivoting is done. Then we say to obtain root, check out the processes with psaux. You do that if one does that. So let's detach. I would say let's do psaux here, and we get this particular process, and simply execute the command this one. This will grant you a tmax session with an open root shell. And here we can put a simple like, okay, not this, was it this? Yes. Who am I? Root. And essentially we're good. So now we're good with everything, and there's nothing else to see. So here the vulnerabilities were, to recap, 3 for the foothold and 1 big one for the privilege escalation, which is if you have open sessions that have root shells open, like with tmux, you should not leave them so that everyone can read them, because here there's also another misconfigurations. I would say here we could signal 2 things differently. One is this socket is open to a current session root, so there's a session root that is not closed. And another is that the user hype can actually use this socket. You can actually interact with this because look, this is in the group hype, and the group hype can read, write, and execute over this file. So this is not good. So you can write here 2 vulnerabilities, root session open without authentication mechanism, and the tmax socket file was not properly configured. The tmax file allowed the hype user to use it. Combining these two, we have essentially privilege escalation. Now it could be argued whether this stuff should be by policy, like maybe in the design of the system they say, no, look, this socket file has to be used by hype. Then the problem is that, okay, then you shouldn't leave root sessions like that, not attached to that particular socket. By the combination of these 2 things, we obtain our vulnerabilities. Here are 2 things to note. And so this is it for this machine. I hope you learned something. You learned something about HTTPS, about Heartbleed, about just how to structure a repo like this. I think it's a very simple and fast way to understand the structure of the machine. And maybe in the future I will do other machines, also depending if you like them or not.